Today we will go over section 6.2, which is vector addition. In this section, we will go over how vectors can be used in physical situations. Now, to understand why we need vector addition, let's consider this case. Imagine a cargo ship, which is this one, and it is being towed by two tugboats in two different directions. I don't know its magnitude, but I can denote it by F1 and F2, and which are forces applied by tugboats onto the cargo ship. Now, from the picture alone, I can make three assumptions. One, direction of the force applied is indicated by the direction of the arrow, meaning the direction of the arrow right over here, so this moves this way and this moves this way. Two, magnitude of the force is proportional to the size or length of the vector, which we learned before. So longer the vector, greater the force applied. Three, I know that the forces applied by these two tugboats have a common point on the ship, which is right over here. Now, what we are trying to predict is what will be the direction of the ship and with what force will it move. Because I see that F2 has a bigger magnitude because it's longer, so let me erase this so you can see. To determine where the cargo ship will go, I need to use vector addition. If we draw only the vectors from the picture given to us, we will obtain this image. Now, to add these together to find a resultant of these two vectors, I take one of the vectors where there is no arrow and put it at the end of the arrow for the other vector. So meaning if I started with F1, I took F1, this as a whole, I bring the end, the tail, and this is the head, I bring the tail on top of the arrow of the other force and draw it like that. So I would add the vectors like that. Now I can also do this other way around. Instead of putting F1 on top of F2, I can put F2 on top of F1. All I need to do is get this F2 by its head and put it on by its tail, and put it on the head of F1, right? And then it will go like this. Remember, I cannot put it in a way that these two arrows are facing each other. So it cannot be like this and then you bring F2 like this. That's not how you add them, but it has to be in this format. Now, to find the resultant force, all I need to do is draw a line starting from the initial point, which is here, to the end point. So my end point is here, right? So the resultant force is this, drawn in black. This represents the movement of the ship, the direction of it, as well as the resultant magnitude. This method is called the parallelogram law. This law doesn't always occur where the directions differ. If we have two forces that are in the same directions, let's say, we can also add them together as well as the opposite forces represented by these images as well. The only difference is when we add them together, we add F1 plus F2. However, if F1 is going in this way and F2 is an opposite vector, then this is going to become a negative F2 because it goes in the opposite direction. So technically you do add them, but you're putting negative sign in between. Now, given vectors A and B such that the angle between the two vectors is 60 degrees, I have the magnitude of A as 3 and magnitude of B as 2, and we need to determine the magnitude of A and B added together. So we talked about when we have two vectors like this, all we need to do is put one of them on the head of the others, right? So over here I have A and B, which I have 60 degrees between them. So to add this, add A to B like that, I can put that B over here just like that, and my resultant vector would be starting from the starting point and going until the end. So this is my resultant, which I'll just call R. Now, in order to find the magnitude of A plus B, I need to realize first what I know about this vector, right? I know the magnitude of A, which is 3. I know the magnitude of B, which is 2. And I also know the degree between them. Here, because this is 60 degrees, I can put this as 120 degrees right over here. So I also know the degrees between them. If you remember your triangle laws, we can use cosine law to solve this. By the way, we found the degree 120 degrees. That's because we divide the 60 degrees by 2, here would be 30 degrees. And I know if I added the other way around onto the B, I added A and added over here, I will also have, because this is going to be 60 degrees as a whole, I also have 30 degrees on the other side. So this is also 30 degrees. I know for my triangle the total degree is 180 degrees, therefore the degree left for between A and B is 120 degrees. Now I put the cosine law up. All I need to do is apply that to what I have. What I have is A plus B, the magnitude of it, that's actually the R that I represented. So I'm just going to switch that really quick to make it A plus B, right? And if I take the C as my A plus B, all I need to do is square this. AB are the same, ABs are the sides, so all I need to do is take the magnitude of A, square it, and onto here, all I need to do is plus the magnitude of B and square that, and all I need to do is minus 2AB, so now I don't square it, but I still put 2 and A, B, these are times, and then cos the degree I have between them, which is 120 degrees. Now, because I know my magnitudes for this, all I need to do is plug that in. So I know the magnitude for A is 3, I know the magnitude for B is 2, and same things over here. And from here I can just put it into my calculator. I get a value of 19, but that value is when this is squared. So because I'm trying to find the magnitude of A plus B alone, all I need to do is root both sides. So as an answer for the magnitude, I get root 19. Or if you want to get an approximate value, I get a value of 4.36. So the textbook also mentions what is called the triangle law, which we did before. So triangle law is basically when you have A and B values, and when you have A plus B here, where you use the cosine law. But don't get confused in terms of the addition itself. The vector addition process is the same. You put that B on top of A, top of A meaning head, at the head of the A. Same thing over here, you can put A on top of B over here. So vector addition is the same, it's just what you use to find the magnitude is differs, and you just use the cosine law and it's easier on you. As soon as you apply the vector addition correctly, you don't need to state which law this is unless the question asks for it, which happens very, very rarely. And there's also something called the zero vector. This occurs when two vectors that are opposite but have the same magnitudes are added. Think about the same boat in the first slide. If I were to pull the ship in opposite directions and their speeds are the same, ship won't move at all. Therefore, the resultant for the ship would be 0. If you encounter a problem where it says A minus B and asks you to sketch it, take the vector which has the negative sign, and as we learned before, just flip it to make it an opposite vector. Because this B arrow does not represent negative B, we have to do the flipping. Then we do vector addition to find the resultant. Now suppose you were giving the vectors A, B, and C as shown below, and using these three vectors we need to sketch this. So don't get confused by the negative on there. This is still vector addition. All this is saying is use the opposite vector. This is actually in the form of A plus negative B. Okay? So what I'll do is I first check if these are in the form that was given to me. First I check A, which is positive A, and I check over here it's the same, so that stays the same. I don't do anything, any alteration whatsoever. Now I check B and I see that negative sign there, but this does not represent the opposite vector of B. So what I do is I draw the opposite vector of B. When I do that, it will look something like this. So the same thing, it's just the opposite in direction, and I'm gonna label this negative B. Next thing I do is I look at C, and if it represents the same thing, yes it does, so I'm done with checking. The next thing I do, I start with my A, then I'm going to add B and C on top of this. When I add the B, all I need to do is take the tail and put it on the head of A. So when I do that, I'm gonna get B starting like this and ending right over here. So this is my negative B. And from negative B, all I need to do is take C, take the tail of C and put it on the head of B right over here. And when I do that, I'm gonna get something like this. And this is my C. And if they want us to find the resultant, so resultant is actually this. So that's what they want us to find. All I need to do is start from the starting point, which is right over here, and go to the end point. So this right here is actually A minus B and then plus C. And that would be my answer. So more of a word problem. An airplane heads due south at a speed of 300 kilometers per hour. What I do with these questions is I read one by one. So airplane heads due south at a speed of 300 kilometers, which I can represent by a vector. Because I see that it has a direction, due south, and a speed over here. So all I need to do is draw a vector like this. And this is going to be my airplane, which I'll just call A. And meets a wind from the west, so coming from the west, at 100 kilometers per hour. So that I can represent it by just putting it on there, and this will be my wind of 100 kilometers per hour, so I'll just call it W. And it wants us to find the resultant velocity of the airplane relative to the ground. Now, when I'm drawing, I purposely added wind on top of A as a vector addition. Why I did that is when an airplane moves in this direction and there's a wind coming from this direction, airplane will start to tend to move a little bit towards west. But it's not completely going like that because it has a velocity also. Airplane has its own velocity. So the resultant velocity will just be starting from the beginning and going to the end vector right over here. You can think of wind being a component, right? And what I need to find is what is this right over here? What is my resultant velocity? So I can just say A plus W. That's what I'm trying to find. I can just use Pythagorean theorem for this one. So what I'm going to do is say A plus W. So the magnitude of A plus W squared will equal to the magnitude of A squared plus the magnitude of the wind, right? I can take the roots of each side to get a value. A plus W, my resultant velocity, will equal the root of the magnitude of A squared plus the magnitude of the wind squared. I know the magnitude of A, which is 300 kilometers given to me. So I can just put 300 kilometers per hour squared plus the wind, which is 100 kilometers per hour, to find the value of my resultant, right? When I do that, I get a value of 316.23. And that is considered kilometers per hour as well. So I did find the resultant velocity. However, whenever you have questions in terms of resultant velocity relative to the ground, I also need to find the direction. Like, which direction does this go to? To find that, imagine this on an axis, right? So I'll just try to draw it, even though we don't really have something like that. Yeah, so this is my x-axis and here is my y-axis. Think it like that. And I know my A is right on top of Y because it moves south. And I know my wind has an X component, but it doesn't really have the Y component. But because it's added right over here, it has some kind of Y component as well, Y coordinates. But my resultant velocity would look something like that between 1, 2, 3. So that's my fourth quadrant. So it's located in fourth quadrant. So this is 1, 2, 3, 4, if you remember how to label the quadrants. But the degree I'm trying to find is right over here, right? Because finding the degrees starting from here is easy because each quadrant has 90 degrees. But what I need to find is that degree specifically. So how do I find that? I just need to use my tangent law, right? So I can just say tangent equals to, if you remember, opposite over adjacent, right? What's my opposite? So when you look at the opposite of the angle, that's the wind. So the magnitude of the wind over what's my adjacent? That's the airplane. So all I need to do is put these values together. The value of wind is 100 kilometers per hour. The value of the airplane is 300 kilometers per hour. And that would give me a value of 1 over 3. However, this is tangent equaling to the value of 1 over 3. I am trying to find the degree itself. So I can send that tangent as negative, so that would be tangent negative 1 over 3. If you put this into your calculator, what you would get as an answer is 18.4 degrees. But for the degree you get, you need to specify the direction as well. So what I do for this is I say south of east. So we put S and E right there. South of east means it's moving in the south direction, but it also has the east component, right? So this would be my degree, and that would be my magnitude. Now, in still water, Maria can paddle at the rate of 7 kilometers per hour. The current in which she paddles has a speed of 4 kilometers per hour. At what velocity does she travel downstream? Now, here, remember that it says in still water, Maria can paddle 7 kilometers. That means when the water is still, she can actually paddle at a rate of 7 kilometers per hour. However, when there's a current, that difference. So that's why they're asking for what velocity she can travel. So when they say downstream, it means with the current. So if the current goes this way, right? So I'll just draw it. So if this is my current and it's by 4 kilometers per hour, and she goes downstream with 7 kilometers per hour. So it's added together. If they say what velocity, then that's 11 kilometers per hour. So using the vectors, draw a diagram that illustrates her velocity going downstream, which we did over here. So it's on top of each other. If Maria changes her direction and heads upstream instead, what is her speed? Using vectors, draw a diagram that illustrates her velocity going upstream. So if this is my river, my current is not going to change. My current is still there. It's 4 kilometers, whatever. However, now she goes upstream. Let me extend this. Now she goes upstream. What happens is it's in the opposite direction. So 7 kilometers per hour. The resultant would be starting from over here and going up to here. So this would be my resultant. So as a result, all I need to do is say 7 minus 4, which will give me the value of 3. So 3 kilometers per hour is my answer. If you have any problems that you would like us to solve, or you didn't understand a specific thing from this video, you can always ask us on our website and go to our forum section, which we can send solutions to your problems.